Hi, everyone. Thank you all for finding time for today's webinar. Our topic is taking action on your security alerts with Panther and Tines. We hope you find the content valuable. Few housekeeping items before we get started. All lines have been muted, so if you have a question, please put it in the Q&A box and we will answer them during our Q&A portion at the end of the presentation. We'll be sending you all relevant links after the event, including a link to the webinar recording. I will now turn it over to our two presenters, Jack and Thomas, for brief introductions and topics that they will be covering in today's session.
Awesome. Thanks, Nadia. Hey, everyone. Happy Thursday. My name is Jack Naglieri. I'm the founder and CEO of Panther Labs. And with me today, I have Thomas Kinsella. Thomas, would you like to give a quick intro?
Yeah, I'm Thomas. I'm one of the founders and COO of Tines Security. We're a security automation company.
Yeah, and today we're going to be talking about automation. So let's start by talking about a problem that all security teams face, which is keeping your alerting under control as you scale your detection and collect more data. So logically, if you think about it, more input in the form of security data results in more output, which is alerts for our teams to handle. The more alerts means more action items, verification, investigation, and most importantly, our time. So what can we do to get this under control? We can leverage automation to do this for us. And today, Thomas and I are going to explain how this is made possible with Tines and Panther, and we'll step through a couple helpful patterns to help ensure the success of your teams going forward. So the way that our platforms sort of work together is that Panther is really used for detecting and investigating any suspicious activity happening in your environment at an extremely high scale. When something happens, we send alerts out to our team to triage, and this is where Tines comes in and takes a hold of the response.
So when alerts are generated by Panther, they often have a lot of great context and are high fidelity. But as Jack said, as you get better at detecting, you generate more alerts, you have more to respond to, and teams quickly realize that the manual process of responding to alerts doesn't scale. So things like reaching out to users, enriching alerts, or analyzing alerts, or taking actions, they're pretty easy when you're a small team, but they're a lot harder as you get better at detecting. So Tines is an automation platform that's built to allow analysts to build their own security automation responses to various different scenarios. So using a joint solution like Panther and Tines, when an alert gets fired by Panther and gets sent to Tines, analysts can automate those manual steps like enriching, reaching out to users, creating tickets, isolating machines, blocking domains, all those time-consuming steps. And what that allows you to do is it allows the humans in the process to focus on the things that matter, those high confidence alerts, and making those decisions that we trust only humans can make.
Right, and there's a lot of benefits to a joint solution like this, or just this idea of using our tools together. So the first one is, as Thomas was just saying, we want to keep our team focused on the high severity, true positive activity. We don't want to be chasing down things that could have just been easily prevented by maybe pinging a user or getting some additional context that gives you the full picture. This also avoids burning out your team over time, right? If you're doing the same repetitive tasks every single day, it's going to get old really quick. And more importantly, these are really scalable and repeatable patterns for the future. So both Panther and Tines are designed in a way that are very customizable, very, very pluggable, and you can really mix and match it to work in whatever fashion you want as the user. And both of our platforms are scalable. We built them for cloud-based teams. We built them for cloud-based scale. And we want to make sure that for the next 5 to 10 years, like these platforms will last as data volumes continuously increase. So what does this look like in practice? Let's take a look at a high level end-to-end how this works. So Panther is really responsible for really being the first step in this pipeline, which is collecting and analyzing and parsing all of your security logs. So this could be data from your SaaS applications, like G Suite Box, from Login, Okta, et cetera. It could be logs from your network sensors, your endpoints, your clouds like Amazon. And we take all of that data, we normalize it into a common format, and then we apply our real-time detections on top of it. So as soon as it's streamed in, we're analyzing it with Python that is fully customizable in our UI or on the command line. And then we fire off an alert when some pattern is matched in our detection, and then that's where Tines will come in.
So Tines has a really simple way of consuming alerts, just a simple webhook agent, which I'll explain a little bit later. But basically, we're able to accept alerts from any source, and Panther is obviously one of our favorites. The next steps that you want to take, they can all be done in Tines. So we're agnostic as to the steps that you want to take and the tools that you want to integrate with. But if you want to ping users and ask them for more information using Teams or Slack, if you want to hit external APIs to enrich the alerts like virus total or gray noise, if you want to take automated actions like creating tickets or dumping memory or creating evidence folders or isolating machines, all those manual steps that would normally take a lot of time, you can do incredibly easy using a tool like Tines. What that allows is it allows you to obviously only investigate the most high confidence alerts, but more importantly, it allows those analysts that you're paying, and it's really hard to attract good security folks these days, as I'm sure everybody here knows. It allows them to focus on the more impactful risk reduction efforts, and frankly, the more interesting process of building detections, hunting, all that sort of stuff, which you can do in Panther to make both solutions more effective.
So let's make this real. Let's look at a end-to-end scenario, and let's understand how all these pieces work together and go deeper on all these different concepts that we're talking about. So for this first scenario, I'm going to introduce, we're going to be monitoring anytime an admin is assigned to our Okta account. So the way that this works is that Panther is continuously pulling Okta logs. It can be set up just with an API token. And then we have some built-in analysis around this specific detection to say, anytime someone's granted any type of admin role, send an alert. And as you're probably thinking, Jack, that's probably going to be a little bit noisy. So this is why we're feeding into Tines. So we feed this alert into Tines for the first step of triage and really just handling the entire response. What this is going to do is it's going to hit the virus total API, and it's going to say, is this a malicious IP address? Like, is this actor who's assigning the IP coming from a known bad place? Then what we'll do is we'll verify this activity with the user as a second step to say, hey, we noticed something weird about this admin assignment. Did you actually do this? They'll say yes or no. And then if they say no, what we end up doing is we lock out the accounts and we kill the session. And then we create a case for our security team to come to the rescue and figure out exactly what happened. And because SSO is really kind of the gateway for accessing any internal systems, we want to highly scrutinize this activity and really make sure that all of these actions are as safe as possible. So in this case, me, Jack, I'm the person assigning Thomas admin creds, but I didn't necessarily do it. So let's go through and understand this a bit more. So again, the way that we pull logs in Panther, you go to your sources and you essentially just say, I want to onboard an Okta source, and then you feed an API token in, and then we start pulling the logs. And then you'll be able to see on the log analysis overview, we have the data coming in, and you can see all the other logs as well. And then on the source itself, it'll say, okay, we're receiving events. This was the last time we received it. You get a little healthy check on the bottom, so we know everything is good. I mentioned before that Panther does normalization, and the way that this works is that we take whatever the raw format is on the left and we convert it into the format on the right. And what this does is a couple things. It allows us to write our detections because now we have keyed attributes for our logs. So now we can say bucket instead of having to do like a substring match or something kind of painful on the left side. And then we also get the benefit of extracting indicator fields like IP addresses, as you can see on the last field on the right here, and just other helpful things that will be really important for threat hunting and just really going through your data in a way that is scalable over time. So with that, well, we're doing this with our Okta logs as well. And Okta is natively in JSON, but we actually are adding some additional metadata and fields, which allows us to search it in SQL. So the general workflow in Panther is let's get some data in, let's use some of our built-in rules and get some good signal, but let's also craft our own detections in Python after understanding what is the data that has already been sending. So what I have here is a SQL statement that is essentially just looking at our Okta system logs. And this is using our connection with Snowflake as well. So Panther has the option to send either Athena or Snowflake. And we really put a lot of work into building out this data lake for you, so you can feed huge amounts of data through this pipeline and get the benefits of the detection and being able to search over it historically. So what I'm looking at here is I want to know all the successful times that someone was granted administrator, and this is going to inform how our detection is built. So this just gives us a sense of like how often it occurs, what it usually looks like, and just other helpful context for us as a security engineer to say, okay, let's build a good detection around this. And then you can see like the types of administrators being assigned on the right. So super admin or org admin, and there's not a whole lot of consistency. Actually, on the last record, there's a comma, so there's admin is sometimes uppercase, sometimes lowercase. So we have a couple of different conditions. So let's write our rule. So in Panther, all the rules are written in Python. There's a bunch of functions that you have to really control how the detection works. The first one is our rule function. This is the most primitive one. It takes in an argument of an event, and then it allows us to do really just conditions based on the attributes of that event. So we're looking at the event type is some privilege was granted. We want to know that it's successful, and then we want to basically just do a regex on the privilege granted. So as I mentioned in the last slide, sometimes it's like a capital, sometimes it's lowercase, and obviously you can do this however you want. There's no really right or wrong way. It's Python. It really just comes down to your own preference as an engineer. So we have our main detection logic here, and then under it we have our deduplication logic, which controls how these similar events are grouped, and then we have our alert context. The alert context is going to be really helpful for forwarding to Tines in this case, because the way Panther is really working is that it's analyzing a large slew of events, and one alert might have 10, 100, 1,000 events associated with it. So the alert context allows us to extract out those pieces that we really care about that we want to forward onto automation. In this case, we're looking at the actor, the target, and the client, which is essentially information about me, Jack. It's information about Thomas, his user as well in Okta, and then client, which is metadata about that request. So we'll see that in a moment when we go over the Tines. So let's say theoretically that my account is compromised, and maybe it's Thomas who compromised it. Why would he be getting admin rights? Maybe he's the suspect in this case. So we need to really investigate this and figure it out. So what this looks like in Okta, if an attacker got in, they would go to the ad administrator, they would make him an org admin and an app admin, and then we would see this. So in Panther, we get our first alert saying Jack granted org and app admin to Thomas. We get some metadata about this alert. We see that the destinations are set to Tines, which is sending via a webhook. And then we also get some other tabs here. So we have an alert summary, which gives you a lot of helpful statistics about these events. In this case, it's just a single event, so it's not as needed. And then the events itself allows you to see the raw events in JSON. So this is where Tines comes in. So I'll let Thomas take it from here.
Yeah, so when one of these alerts normally fires from something like Panther, there's a lot of steps that you can take. And what I'm going to describe is probably, it's a reasonable scenario, but it's not by any means the absolutely perfect scenario. But if you think about what the manual steps that you normally take, if you saw, a user assign another user admin rights in Okta, you'd probably investigate it very, very quickly by just, checking out the IP. You'd probably create a case just to track what you're doing, maybe in the Hive, maybe in Jira. You'd then, if you found out some information, like from investigating the IP in virus total or something like that, you'd say, hey, that's a bit suspicious. Jack is in San Francisco and, this happened in New York or something like that. You'd say, okay, let's contact Jack and ask him, did he perform this activity? And then if Jack says yes, you'd do something like, close the case or update the case and close it out and say, this is absolutely fine. If Jack says no, you might do things like lock Jack's Okta account. You'd definitely page on call. You may try to block that IP address in your firewalls or block that IP address from Okta, and you update your case, etc. That's the manual steps. And if you look at the information that Panther has sent to Tines, we have a huge amount of information that we can already have to make a decision on this. So Tines has this webhook agent functionality where you drag a webhook agent onto what we call a storyboard. And that's just part of your automation stories or your automation playbooks. And when you drag it on, Panther can send information, and we parse that information in a really nice way and make it visible to you in a really easy fashion. So if you look at this alert, you can see that Panther has sent data about this, about it. So the ID is Okta.admin role assigned. The severity is informational. That's because this happens pretty frequently. It's nothing to be terribly afraid about. You can see that the actor that performed it, their display name is Jack, their type is user, their alternate ID is Jack's email address, and then the target was Thomas@Tines.io, display name Thomas Kinsella. You also have the client device information, some information about the user agent, and some information about the IP address used. So if we think about the steps that we manually take, you can actually take all of those steps that I mentioned that you could take manually, you can take them in an automation platform like Tines. So this is what a Tines story looks like. A Tines story, every single one of these blocks represent an agent. An agent is a worker in your Tines story. And they just represent a single step that you might take to respond to an alert like this alert. The different colors represent different types of alerts. The value of Tines is that there's only 7 agent types that you need to understand. And if you're able to understand those 7 agent types, you can see them in the top right-hand corner: webhook, IMAP, email, HTTP request, trigger, event transformation agent, and send to story. If you're able to understand those 7 agent types, you're able to automate pretty much any process. We're agnostic as to what the process is. So this process, as I said, it will fit a lot of like what a reasonable response to an information alert like this is. But it like you may find that you're saying, actually, I'd probably like to isolate Jack's device as well, or I might want to trigger and ask Jack even if this IP isn't bad, if it's in a different country or something like that. All of that is really, really possible. This process that we're going to talk about a little bit further is the very first thing we're going to do is we're going to create a case in the Hive. We're then going to, that's just to track what's happening. We're then going to search for the IP address in VirusTotal. We're going to trigger if it's known bad. If it's a simply unknown reputation or it's known good, we'll just update the case and close it out in the Hive. If it's known bad, though, we're going to search for Jack's user account in Slack. When we find Jack's user account, we'll get his user ID and we'll send him a message. And then based on Jack's response, we can take a few different actions. So if Jack says, yep, that was me, I recognize this, we'll send him a message saying, hey, thanks for letting us know, everything's good, we'll close the case. If Jack says, I don't recognize this, we're going to search for Jack's user profile using that email address in Okta, and then we're going to suspend his account in Okta immediately because clearly something's happened and his account's been compromised. We're going to send him a message on Slack saying, hey, you're going to be in trouble, your account's been compromised, and we're going to take some actions, and then we're updating a case in the Hive. We can also obviously do things like alert people in PagerDuty, etc.
And Thomas, are you able to share these stories as well?
Yeah, absolutely. So this story can be shared. We'll put it up on our on the blog afterwards, and we'll send it out. These stories are they're super flexible. You can just download them as simple JSON objects. And we've got a whole load of templates as well that we can give you for any sort of automation story like this. This is a pretty common story that we talk about. I want to dive into one or two of these agents to show you what they look like. So when I say, the very first type of agent was a webhook agent, we say that we're able to integrate with any tool that has an API, regardless of whether it's a commercial off-the-shelf tool or a custom, homegrown tool that you have. The reason that we're able to do that is this HTTP request agent allows you to connect with those tools directly. There's no need to write a Python module. There's no need to build an integration. There's no need to wait, for expensive professional services to give you a quote and then come back 3 weeks later. You can see here we're connecting to the VirusTotal API. We're just hitting that API directly. We also have parameterized requests. So what that means is that we can pass through data from the previous agent in the story or any of the previous agents in the story. So here you can see we're querying VirusTotal. We're passing through a credential. We're querying VirusTotal with the data that was at the path that was sent from Panther, the webhook agent body.alertcontext.client.ip address. And when we query VirusTotal, VirusTotal will give us a huge amount of information back. Remember, we don't really care what tool we're integrating with. We've got templates for hundreds of security tools. So if you wanted to check this in Abuse IPDB, if you wanted to check this in Grey Noise, if you wanted to check this in any other threat intel platform, you're going to be able to do it. You're just going to change this agent around slightly or use one of our templates. It's going to be super simple. When you hit that when you hit buyer's total, you'll see that you get a lot of information back. So all the information that buyer's total gives you and all the information that's usually on the web page, Tines will give you, and you're going to be able to take action on that. So if you see here, what you can see is that the buyer's total has told us that the country is France, the continent is the EU. It actually gives us some more information below as well. It has given us our who is information. And it's also given us some really cool information as well about the last analysis stats. What that is it's telling us the last time this IP was analyzed, that you can see in the center, 80 engines thought it was harmless, 7 thought it was malicious, 0 suspicious, 0 timeout, and 10 undetected. That's pretty bad, to be honest. If Jack has performed an action, and first of all, if he's in France, which is something that's suspicious, but also if he's performed an action on an IP address that's known as malicious, we should probably take action. The way we can tell that it's malicious in Tines, we use one of the other agents, a trigger agent, and that's the next agent in the story, to trigger if known bad. And what we're doing is we're going to check if the value at that path search for IP address in buyer's total .body data attributes last analysis stats malicious, a bit of a mouthful. We'll check if that path has a value that's greater than 1, and we can see here that it's got 7. So as a result, it's going to trigger that agent and pass through to the next agent in the story. If you remember the next agent in the story, we looked up Jack's user ID and then we pinged Jack on Slack. We can then pass through all the information that we got from buyer's total and all the information we got from Panther to actually give Jack a lot of context on what this activity was. So we can see here we've passed through some information about the alert. So that's the data up there, new alert, Jack granted admin access, administrator all privileges to Thomas. Jack, do you recognize this activity? We've got the device used, that came from the alert. We've got the IP address used, and we've also enriched it with that information from buyer's total, the location in France that I'm not going to try to pronounce. We have also got the IP reputation. So we've established that this IP was malicious. And if you were to click that link would bring you to buyer's total, where Jack could do a little bit more digging and be like, hey, hold on a second, is this potentially actually me? Maybe I was using a free VPN when I was using my phone or something like that. In Tines, then, or Jack clicks that link, and then Tines will take the next step. And the next step is to update that ticket and say, hey, this is actually a severe, a high severity alert. Here we're using the Hive. We're big fans of the Hive, but you can use any platform out there. And we've added some really cool information here. So just data about the date that this action was taken, the device used, the account that was actioned, the IP address, and we've also added some information to say Jack has indicated that he doesn't recognize this activity. The other piece of information that we then, the other action that we then took was we isolated Jack's account in Okta, and we locked him out, so he's no longer able to do anything. This obviously can then, you can see this is a high severity alert now. You can obviously get humans involved, and humans can take the interesting detections or interesting decisions around how did this get compromised? What else do we need to do to clean up this? Do we need to perform forensics, etc.? But Tines has taken all the actions necessary to kind of contain this incident immediately, which is what's really important.
Great, yeah. So let's do a little recap on this scenario. So starting from the beginning, we had data coming in. We had our Python detection flag the admin assignment. We also stored this in our data lake for forensics down the line. But what we also did is we passed it into Tines for that initial level 1 triage that every analyst really goes through when they see an alert. They're like, okay, I want to know the IPs. I want to understand the traffic. I want to reach out to users. I want to have as much information as possible. So Tines does this for us completely. And then what we get is that automated response as well. So then the security team can go in and really just take further action, kind of like that tier 2 response. And a lot of these workflows are super repeatable, very customizable, and they can really fit whatever workflows that your team may have. But I think another really important thing to keep in mind here is that this is really a data-driven security workflow. We're hitting APIs, we're analyzing responses, and this is really an important pattern, I think, going forward. It's not so much looking at graphs anymore and looking at dashboards. It's more so writing code or using services like Tines to really analyze responses and really just make our team successful in the future. So let's go a little bit deeper on this. So let's talk about one more scenario, and then we can go into some questions from the audience. So in this second scenario, what we're going to end up doing is instead of feeding it into Tines as the end result, we're going to actually create a feedback loop and post-process this data into Panther. So the way I always like to describe what Panther is, I like to say security data analytics. And part of that is like really creating these input-output pipelines. So data comes in, we do some analysis, data goes out. But what we can do with Tines is we can actually do this enrichment on our alerts. We can feed it into an S3 bucket with Tines, and then we can reprocess it with Panther. So this allows for a couple of different things. I mean, for one, you get that history stored in the data lake. As I mentioned, all the data coming in is searchable in SQL, and you can do a ton with that. You can join it against tables. You can just have this essentially like infinite history in your data lake as well. So let's step through a little bit on how this works. In this scenario, also, we're going to be analyzing CloudTrail data instead of Okta data, and we're going to be flagging root logins. So if anyone saw the last webinar, this was the topic there, root activity. A lot of it is actually similar events that I repurposed for this webinar. So we see our initial root login from this IP and this account, and we get our initial alert. So it looks a little bit like this, and we're going to actually feed this again through Tines. So if we look at some of the context here, we see the event names console login, we see the time, and then we get our alert context, which is just information that we feel will help Tines take the proper action. In this case, what we're going to end up doing is looking at the IP address again, and we see again a very similar, a really similar sort of input to the last scenario, except we're looking at root logins, and then we're going to get some information on this. So I'll let Thomas explain how Tines is going to handle this scenario as well.
Yeah, so as I said, in the last scenario, we took action. We performed a pretty end-to-end security response where we went all the way up to isolating machine, creating tickets. Here we're not quite as confident. So root logins, I wish they didn't happen, but they happen pretty frequently, and it's not necessarily the case that you're going to be able to contact a user every single time it happens, mostly because it's root, so you don't necessarily know who did this. But you do still want to be able to investigate this, and you do want to be able to enrich this and get some more context. Fortunately, Tines is really flexible as to what you want to do and what you want your response to be. Sometimes you do want to take an action, sometimes you just want to enrich. The other thing is that sometimes the enrichment process can be very expensive. So you only have unless you've got a limited budget, you only have a limited number of virus total credits that you can use every single day. You only have a limited number of gray noise credits that you can use every single day without, running into budget issues. So if you flag certain alerts, you can send them to Tines, and Tines can take an action on them. We can see on the left-hand side of this page here that Tines is just taking, it looks like one action where we're analyzing that IP address. In reality, what we're doing here is we're using what we call a send to story. So Tines is extremely flexible, but the process of analyzing an IP address, you do that in a whole load of different places. So if you get, a suspicious login, or like we did in our previous scenario, a suspicious admin action, you definitely want to analyze an IP address. If you're analyzing, email headers, you probably extract IPs and want to analyze the IP addresses there. If you've got a root login, you want to analyze the IP addresses, but it could be 20 or 30 scenarios where you want to analyze IP addresses. So instead of building out that process in 5 or 6 stories, or 10 or 20 stories, you're able to use this send to story functionality to build what we call a global function to analyze IP addresses from anywhere that you want using one agent. So here in Tines, we send to this sub-story, and what we're doing is we're getting the IP who is. So we're looking in risk IQ to see, who owns this IP, where is it? We're then searching for the IP address in virus total, as we did previously, and then we're looking up the IP in gray noise, another great threat intelligence tool. And we're then selecting the results that we want, and we're returning that back to the main story. So the advantage then is that we'll have all this information from risk IQ, from virus total and gray noise, and we can add that to an S3 bucket so that can be re-ingested back into Panther. Obviously, Panther will be able to store that forever. You'll be able to form queries against it, and you'll have a record of all of this activity, and you'll be able to actually, perform additional correlations in Panther, as Jack will talk about.
And you can have that history over time. So if the IP becomes malicious or benign at one point, you can actually store those responses. So the way that we're able to write the detections and store it in the data lake is by using schemas. So by default, Panther has a lot of supported schemas for a ton of security logs, like OS Query, OSSec, CloudTrail, all the Amazon ones. It's a pretty big list, but you can write your own. So the way that you write your own is by using this YAML declaration file that we have, and pretty simple to get started with it. You just essentially are giving the names and their types, and then we'll do all the rest for you. So what we're doing here is we're creating a schema based off of these API responses, and then this will allow us to write an additional detection and to store it in our data lake. So let's look a little bit on how those rules would work. So in Panther, what we can do is we can create our detection using a couple of different built-in libraries with Python, but we're essentially doing similar analysis to what was happening in Tines, where you're saying, show me how many positives there are on the detected communicating samples. In this case, I'm setting a pretty high threshold of 50, and then we're going to do some additional logic to determine if it's benign or not. So the beauty with Python is you can do as much as you'd want here. If you want to process the risk IQ output as well, in this case, I'm looking at specifically virus total and gray noise, but you can add really whatever logic you want here to determine what your threshold is as a security engineer. And then what we're also doing on the bottom is we're interpolating our title based on the result of this analysis. So this will essentially always trigger, and in Panther, you'd be able to see that first alert, and then you'd be able to see that second message saying like, okay, it's actually benign. You don't have to worry about it. So what that ends up looking like is something like this in Panther. And so we see our first alert, root logging detected, and then we see a second one that's just informational saying, hey, it's actually fine. So I wouldn't worry about it. And then you can look at the time created. It's about a minute latency. So real time is really important for really both of our platforms. The fact that we can stream all this data through from CloudTrail all the way through Tines and then back into Panther within a minute is pretty incredible, and is really going to help with that fast response in triaging these alerts. And then again, being able to search this with SQL is extremely powerful as well. So if you want to say, show me all of the detected download samples where the IP address is known and it's known bad, and then you have this response stored, and you can really do whatever you'd like with it. So to recap, what we did, again, we flagged that initial activity that we were really interested in. We sent it into Tines for automating these lookups. We used a repeatable send to story pattern with Tines, and then we fed this back into Panther with S3. We post-processed it with Python this time, and then we stored it in SQL, and we created this really awesome feedback loop. So those are the two scenarios that we have today. Just to sort of wrap the whole thing up, we really, again, feel that automation is super, super critical for the success of our security teams going forward. We're responsible for processing such a high scale of data these days, and Panther is a platform that is built for that cloud scale. We store our detections as code, which gives you, a lot of reliability, repeatability, collaboration with your team, and these like data-driven workflows. And then, with Tines, we get automated response.
Yeah, and that automated response can take many forms. It can, as we demonstrated, create cases, reaching out to users, locking accounts. It can be really cool things like dumping memory or pulling back Chrome extensions from a compromised device. It can be, anything that has an API, we're going to be able to do it, and you can create really rich and complex detections and decisions so that you're only surfacing those the richest and most important alerts. But it really allows you to kickstart your investigations. And I think the benefit of both platforms is that they're both flexible enough to fit your needs. So we've talked a lot about patterns, but we're able to, if you take these abstract patterns for these two alerts, apply them to loads of different alerts that could take place from any sort of detection source.
Right. And these days, the data volumes are just so high that, there's so many different things that we want to look at, we want to analyze, we want to correlate, and yeah, both of the platforms together are just going to save you a ton of time. So how do you guys get started? So both Panther and Tines both have communities. We dropped a couple links here to get signed up on both of our Slacks. And Panther has an open source edition that you can go download and deploy today in about 10 to 15 minutes. Tines also has a recently launched community edition, so I can let Thomas talk about that, and then yeah.
Yeah, the Tines community edition is great. We launched it last week, and it is a free full-featured edition of Tines. The only limitation is that you have about 100 agents and 1,000 events a day. But you saw in those two scenarios, or those two stories, that we had, I think, a total of 20 agents across the two of them. So you could create 10 pretty good automation stories for free in our cloud tenant, and yeah, get started immediately. We also obviously have that Slack community. So if you want to jump on and ask us questions, tines.io/Slack, and we'll be able to answer any questions that you have on how to get started.
Yep, and for anyone interested in either of our enterprise tiers for hosting and more information, we both have our sales emails there. And we also wrote up all of this into a blog post. So it's on blog.runpanther.io currently, and it just steps through a lot of the details around the first scenario that we talked through today. So yeah, thanks again for your time. I think we can jump over to any questions that came through and then go from there.
Awesome. Thanks, guys. We have two questions that came through. One of them is, you've mentioned patterns a few times. What are some other use cases folks can use Panther and Tines for?
Yeah, that's a great one. Thomas, do you want to take?
Yeah, sure. So like any sort of use cases where you're dealing with alerts. So we've dealt with two there. So like one for obviously creating a user account, another for root logins, but any sort of suspicious login, or any action that is, I suppose, high fidelity or like high quantity, but like sometimes low fidelity. So that could be a repo being made public, or the permissions on something changes.
Or on like a document or something as well.
Exactly. Things like brute force attacks. You can take actions like blocking IP addresses or blocking domains. Visiting suspicious domains. If you detect that in your logs, you can take action. All your standard SIM alerts. There's a whole lot of actions that you can take.
And Panther has a ton of those out of the box. They're also fully open source. So if you go to our GitHub page, you can see all the built-in detections that we have. I think when we were mentioning patterns as well, I think I was just also alluding to the fact that because Panther is using Python, we can create a lot of repeatable detections. And generally, once you write hundreds of detections, you start to see these patterns that can apply to multiple log types and multiple sort of attacks. Like we try to base our built-in ones based off MITRE ATT&CK, so we use that framework as really a great jump-off point. We also use standards like CIS, PCI, and compliance frameworks. But aside from those, like just the patterns that we have in the products themselves are super modular. You can really mix and match it however you want. So you kind of get the benefit of both of them.
Awesome. We had one come in also. This question is for Thomas, or specific to Thomas. Can Tines agents keep state/remember previous decisions? For example, the IP address check story, is it able to remember decisions made on previous IPs?
Great question. And slightly complicated. Yes is the answer. The way we do that, we'll allow you to basically deduplicate based on previous decisions, or query to check the results of previous decisions. I didn't really touch on the event transformation agent, but the event transformation agent allows you to modify the contents of incoming events, but you can do things like extract out data, you can explode data, you can deduplicate, you can implode. And one of those, those features is deduplicate. So you're able to say, hey, based on the decision that's taken, has this IP address been seen before, and was this decision taken? And based on that, you're able to, I suppose, say, okay, yes, IP address has been seen before and it was flagged as malicious, therefore I should go down one particular path, or this IP address wasn't seen before, so therefore I should go down another particular path. However, if you're looking for, I suppose, a really long period of time, I think using something like Panther is exactly what we should be doing. So being able to query, like using SQL, query your data lake for all historical references to an IP address that have been seen over 6 months or a year. That's not something that we think your automation platform should be doing. We think that that's exactly what Panther should be doing.
Panther can actually also keep state across the detections too. So we have the ability using a cache, and you can put arbitrary state in there. So you can check the past value, or you can check you can keep tallies of things. We actually have a built-in rule for Okta specifically that is looking at geographically impossible logins, which is a common one. So if I log in from San Francisco and then I log in from France an hour later, that would flag it. And it's using this caching capability that I'm talking about.
One last question. Wouldn't detection as code get complex to maintain within time?
Yeah, I mean, I think it really just comes down to your workflows as a team. I mean, I'm biased. I personally think that it's easier because you can set up unit tests. You can ensure that they're going to be reliable over time. And you can actually fully automate the deployment of them as well in your CI. So if anything, you have that source code repository, you have unit tests that validate that they're working over time as they evolve, right? It's very similar to just like writing code in general. You want to make sure that the code is working as you intended it originally. So I think it's actually much more sustainable than kind of like one-off sort of search languages and things like that, where you can't test them and you don't have a way to like programmatically manage it.
Awesome. This brings us to the end. Thank you everyone for joining. We'll be sending out the presentation recording along with any of the links mentioned in a follow-up email. We appreciate you taking the time to join Panther and Tines today. Have a great rest of your day or night. Thanks again.
Thank you.
Thank you.